Well, hello there. So today we're going to summarize all of our work on limits with one big problem, and we're going to look at the limit at 4 points. Okay, now let's first understand that when you're on a curve and you're happily going along a nice smooth curve like this, we don't really need to talk about the limit. I mean, the limit exists, but it's the same as the function value. So, okay, fine. What we're really interested in is what about these points like 4, where we got that action going on? How about -1 with this hole in the curve? Or how about -3 with this vertical asymptote and 3 with that vertical asymptote? So today I want to talk about those 4 points. Let's start with x equals -3 in these 4 questions right here. Okay, now again, you don't have to don't try to copy this down. You can press pause and see if you can work these out on your own. But let's see what happens. The limit as x approaches -3 from the left of f of x. Let's see. I'm approaching -3 from the left. What is the curve doing? Oh, it's shooting straight down. That's right. -infinity. How about the limit as x approaches -3 from the right of f of x? We're going to get closer and closer to -3 from this side. What is the curve doing? That's right. -infinity. Now, those two values are the same. Therefore, we say the limit as x approaches -3 is -infinity. How about f of -3? I'm sorry. There's a vertical asymptote there. Does not exist. Oh, okay. Let's try -1. Again, nice hole in the curve there, if you can see that. Here we go. The limit as x approaches -1 from the left. Well, as I'm approaching -1 from the left, what's that curve getting close to? That's right, 0. How about -1 from the right? As I go along the x-axis, what's the curve getting close to? 0. Those curves are both coming in to 0. Therefore, what do we say about the limit? 0. But f of -1? Sorry, there's a hole in the curve. Does not exist. Okay, let's continue on. How about as x approaches 3 from the left? Let's see. I'm here approaching 3. Where is the curve going? Straight down. -infinity. How about 3 from the right? Boom, boom, boom. Positive infinity. Therefore, the limit as x approaches 3 does not exist. Do you see the difference between this one and the previous two? How about f of 3? Does not exist. Okay. So when will the function value exist, you might ask? Well, let's take a look at what's happening at 4. How about the limit as x approaches 4 from the left? What is that curve getting close to? It's coming down here, getting close to 2.5. How about as we approach 4 from the right? Now I'm out here. Where is that curve? It's coming down to 1.5. Uh-oh. Those two aren't the same. Therefore, what do we say about the limit here? That's right. Does not exist. But what about f of 4? Does that exist? Yes, it does. Look at that closed dot right there at 2.5. Okay? And then finally, our last question is, what's going on here as x approaches infinity. All right? So we say the limit as x approaches positive infinity of f of x. What am I asking you for there? The horizontal asymptote. That's right. What is the horizontal asymptote or slant asymptote? It is a slant asymptote. Look, as x gets really big, what's the curve doing? Shooting off. So we're going to say positive infinity. What about the limit as x approaches negative infinity of f of x? What's going on here? Oh, that does look like a horizontal asymptote, doesn't it? As I go way out here, what is the curve doing? It's getting closer and closer to 1. There's your horizontal asymptote. So, as x approaches a number and the curve goes down or up, you've got a vertical asymptote. As x approaches infinity or negative infinity, you have a horizontal asymptote or a slant asymptote. The connection to pre-calculus. And that is a look at the different ways we evaluate a limit. Good luck. Keep reading.